People, it's Hugo here. In this video, we're going to go through one of Orchestra's latest features, which is called data reconciliation. And the problem this solves is helping data teams easily reconcile data between source databases like SQL Server and target databases like Snowflake, BigQuery, or Databricks. Or if you're a large enterprise, you probably have a combination of these and you're moving data in between them. And it may not even be on-prem. It may just be comparing something like Databricks to Snowflake. Why do we want to do this? We want to do this because if we don't, then stakeholders are going to come to us and they're going to say, hey, this looks a bit strange, this number looks a bit weird. Can you go ahead and reconcile this for me? And that's really annoying. Another reason we might want to do it is also in the case of streaming. So obviously, if you're batching data from source to target, it's fairly easy to say, okay, I'm going to do a data to quality test. I'm just going to run a query or something. But if stuff is streaming from like a SQL server into Snowflake using CDC, Debezium, Kafka, something like Event Hub, and so on, then it's a little bit harder to test because you don't really want to just have another separate pipeline that's just running every day, every hour, querying the entire database on both sides and checking. It's a bit of a faff to set up. So that's a sort of problem that we're going to solve here. And this is just an illustration. So let's say we're moving data from SQL Server to something like Snowflake. This is the time. At that point in time, when we check the SQL Server to see how many rows we've got this many records, right? At the same point in time in Snowflake, we've got this many. We've got 4. So there's a delta. We're missing 2 rows. This is not good. Maybe it's acceptable. Maybe it's not. I'd like to know. I'd like it to be flagged. This is a little bit more detail. We'll go into this in a second, but I think if we just start with a super simple example of how we tackle 2 tables with where we want the data to be the same, we can do that. So I'm going to bounce into Snowflake, and I'm going to create this table called dummy stream table, and I'm going to insert these values into it. So if I now take a look at what we've got, we'll see I've got 3 rows, Alice, Bob, and Charlie. So we're looking all good. Now, what you might have is you might have something like a stream in Snowflake, which is inserting data into it. I'm going to ignore that. I'm just going to create another table called the dummy stream upstream table, or let's call it the dummy target table. Now we can select. All right, cool. So now we've got 2 tables that we want to reconcile. Super simple. So what we're going to do is we're actually going to type Orchestra, which is super cool. I'm going to select manual query, and we're going to say reconcile 2 tables. I'm going to select my source integration, which in this case is going to be Snowflake. I'm going to do Snowflake to Snowflake just because it's a bit easier. And we're going to say, let's select someone from the dummy source table. Then we'll do the same thing, but we'll do the target. And what this is going to do is it's going to select the total number of rows and make sure that they're the same. So I'm going to go ahead and save this. Now we can run it. In the meantime, I'm also just going to go ahead and insert some more rows into the source. I'm not going to do that right now. I'm going to wait for this to run so you can see what happens when stuff fails. Gosh, I'm very white. Cool. So we can see the query results match, which is pretty cool. We're fetching the metadata. I'm way too fast. So we can see the result of the first query. It's cost this many credits. This is the second query. And then we're happy. We've got 3 rows in both, so that's great. Let's insert some more rows. And let's run this again. This should fail. We're going to get 3 rows in the source table. 6 rows, beg your pardon. And then 3 rows in the target. So this is simulating a situation where you're streaming data, you're moving data from source to target, but maybe something's broken. So now you've got data in the source but not the target. Cool. Query results mismatch. Source 6 and 3. So that's good. We've automated that. And that's brilliant. Now, this is a very basic way of doing it. Sometimes if you don't have things like a primary key or an auto-incrementing ID, you're going to have to write 2 queries that are manual. And as we can see in this lovely Excalibur diagram, sometimes you're going to want to make this a bit more efficient and you're going to want to leverage this sort of auto-incrementing ID. The other consideration is that, in this query, what we've done is pretty bad because we've just selected and scanned the whole table. Right? If you've got billions of rows, it's going to be incredibly slow, so you shouldn't be doing that. But what Orchestra supports is a sort of incremental implementation of this. So let's say we start off with 4 rows in each table, and there's an auto-incrementing ID called ID. You can do the test that we basically just did, and if there are 4 records of both, this is going to succeed. Happy days. The cache value is then going to get updated to 4. So this is just a record that Orchestra keeps of what the sort of latest ID is. If we then test again at a later point in time, maybe some of the streaming's gone down and, oh shit, we've got 1,000 IDs here in the source DB, but we've only got a couple in the target, so that's not good. In this case, because we have the cache value, we're going to parameterize the query. So we're going to select from where the ID is greater than the cache value. And this not only makes things faster, but also cheaper because we're incrementalizing the test, which is cool. So I'm going to show you how to do that now. And it's more or less the same. So let's go ahead and edit this pipeline. I'm going to change this task. So I'm going to go back. I'm going to add the cursor field. So in this case, it's a little bit easier because we're just going to take the target name, that's going to be ID. It's going to be ID for the source as well. I'm going to take dummy stream table. And there are a few things we can do. The first is detect count drift. So this is like what we were doing before. We're going to throw an error if there's greater than 0 rows difference in the total count between the 2 tables. If the max is different, so I've got, the greatest value of the ID in one table is 6, and the other one is 3, that's going to fail too. And then adding this helps us do things incrementally. And if you ever need to override that, you can override it here. So let's have a look and see what happens when we run this. And this should fail, right? Because the source has got 6. Target's got 3. Okay, so I have messed this up because I've not specified the correct database and schema. So let's do that. Why do I need to do this? Because there's a default connection ID, and that connection ID has a database and a schema, and they're clearly different to the one I want to use. Okay. Condition failed. So we've got count drift and max drift. Source is 6. Targets 3. It's not good. So let's simulate a recovery and run this again. So now if I look at the target, I've got 6 rows. Cool. All conditions satisfied. Happy days. So that's good. And, because this is satisfied, the cache value is now going to be 6. So the next time we go into this and, run these queries, this query is going to be selecting where the ID is greater than 6. So this credits number is going to be a lot lower because this runtime is going to be a lot lower, which is super cool. And yeah, that's the vast majority of what I wanted to say. But this is obviously super powerful. It's great that you can sort of leverage any integration that you've already got hooked up to Orchestra to do data reconciliation tests, and really, really, really good when you're doing streaming data. The other thing to note is that in terms of things like S3 or data lake storage or object storage, so cloud storage, these are all going to be supported very soon. So if you want these, just ping me a message. Obviously, it's going to be really good and imperative when everyone starts streaming all their data into Iceberg. But yeah, that is data quality reconciliation in Orchestra. If it's interesting, let me know. Likes, comment, all good. And yeah, talk to you soon.